Hello, everyone. A very warm and cheerful welcome to this much anticipated session. A special welcome to all the students, faculty, and our esteemed alumni. We are absolutely delighted to have you here with us today. We are gathered here for a very inspiring conversation. This presents itself as a great opportunity to be learned, to, to be inspired, and to discover the practical guidance that can help us each grow. And especially if you are aspiring to serve the nation and the world through engineering, you are at the right place. I'm Pubalee Sarkar, a third year mechanical engineering student, and I'm thrilled to be your host today for the event titled Exploring Higher Education Beyond Borders. This webinar is part of the Higher Education and Internship Special Interest Group under the IST Shibpur Alumni Networking Initiative, an effort by GAABESU, the Global Alumni Association of IIST. Our mission is to connect students with accomplished alumni, provide career insights, and build a stronger, better informed and student community. Whether you are preparing for higher education, exploring internships, which I know many of you are doing so now, or considering a research career. Today's session has something valuable for all of you. And a quick note for everyone, please drop your questions into the Zoom meeting chat. We'll have a Q&A at the end. And now let's introduce the speaker today. It's my absolute privilege to introduce you to Dr. Monsur Islam, a proud alumni of our institute. He graduated from IST Shibpur in 2013 with in Mechanical Engineering. Since then, his academic journey and research journey has taken him across the globe, from US, Mexico to Germany, Spain, and I will not bore you with any more details. All the details will sequentially flow from the conversation now. Welcome, Dr. Islam. It is wonderful to have you here. To start on a lighter note, could you share a fond memory or maybe one thing you really like or miss about IST Shibpur?
Thank you, Pubalee, for the introduction, and thank you, GAABESU, for inviting me for this session. There's a lot of memories. It's a big list, like from the very first day to the last day. But the thing that I miss most is like being with my friends, like being in that hostel. Especially, I was in Ulfenden, with all my friends, with all my wing mates. It was amazing. I miss those days, especially the biryani nights, like staying in the queue in the hot summer in that kitchen with sweat and everything, waiting for biryani. Oof, I really miss those days. Whenever I talk to my friends, we always talk about this.
Okay, that was fun. And Wolfenden is a very famous hall, like
Yes.
seriously.
Yes.
So now, after, could you please like share about your research work presently and your current institute?
Sure. I have prepared a presentation for a few slides. I'll just present them. Let me share my screen. Can you see my screen?
Yes, yes,
Okay,
yes.
perfect. So currently, I am in the Universidad Politécnica de Madrid in Spain. It's Technical University of Madrid, and the work that I have been doing for the past 7, 8 years across different institutes. The moral of the work is basically 3D shaping of pyrolytic carbon. I'll just briefly touch what I have done in each institute, like the brief research work, and coming to my current institute. So this is kind of my CV in a way. So I did my bachelor's in from IIT Shibpur, of course, and then I was there in IIT Kanpur for few months as an research assistant, and after that I moved to USA in Clemson University to do my PhD in 2014. I graduated from there in 2018, and directly after that I joined Karlsruhe Institute of Technology in Germany. So I spent there like 5 years. I was there initially as a postdoc, then I became a group leader and principal investigator. And after that, I got this very prestigious Marie Curie Fellowship. So with that fellowship, I moved to Madrid. It's an institute called IMDA Material Institute. It's kind of like our CSIR labs, but from Madrid government. And recently, I got another fellowship that allowed me to join as an assistant professor in the Technical University of Madrid. I recently joined, like last week was my first week in the institute. And along this journey, I was fortunate to visit several other universities. Like during my bachelor's, I went to University of California, Irvine. I went to IIT Kharagpur. In my PhD, I spent few months in Georgia Tech, in Tec de Monterrey in Mexico. Then during my postdoc also, I spent few months in Kyoto University in Japan. So it's been a very fruitful and exciting journey for me. Coming back to the research, the main core of my research is pyrolytic carbon. It's a allotrope of carbon. You know, there are many different types of carbon from graphene, CNTs, amorphous carbon, diamond. The one that I work on is glassy carbon, which is a form of pyrolytic carbon. And the way you get the pyrolytic carbon is burning a polymer precursor in a inert atmosphere. And at certain temperature, the polymer breaks down to carbon. Um, so in my so this work started actually when I was there in UC Irvine as a intern student, and there I started doing these carbon MEMS where you kind of pattern a photosensitive polymer using light and then convert them into carbon by burning them, right? And I continued that work during my PhD also, and you can make different kinds of shape, and mostly they are 2D, 2.5D kind of structures like pillars at the end. And I use them this kind of micro pillars, combining with an electric field and a microfluidic channel, and for basically biomaterial analysis, like cell analysis, basically. So you can do cell trapping, cell enrichment, cell filtration, this kind of things. And this is one of the part of my research was this carbon-based dielectrophoresis. And other than that, also during my PhD, we started thinking how we can shape the carbon in more 3D complex way. And one of the ways that we explored, and we also have a patent on that, is basically this carbon origami, where you can take a sheet of a polymer, fold them into origami. And I believe we all know origami. When we were kids, we used to make these little like boats or birds, these kind of things. But here, instead of making beautiful things, we are making more engineered structures. Here you can see one of the structures called 𝗵𝗏𝗏. So once you make the structures, you again burn them to convert them to carbon. You can functionalize this material to convert them to other kinds of material, for example, carbon metal composite, carbides, these things. And the beauty of these things that just by folding papers or folding a polymer, you create some lightweight, highly stiff, highly strong materials, which is otherwise not possible with traditional machining based process like lathe or drilling, milling. You cannot achieve these kind of structures with the traditional process. That was the beauty of this process. So moving from there, when I went to KIT, I wanted to explore different other ways where I can convert different polymers into carbon. So I explored different methods. One of them was I go from bottom to the top. So one of them was this one is called laser induced graphene, where you take a laser beam and by tweaking the laser power, you just write on any substrate. It can be a film, it can be paper, it can be clothes, it can be wood, it can be any flexible substrate also. What happens, you give enough power so that the material converts into carbon. And in that way, you can uh, write any kind of 2D pattern you want. The same way when we explore electrospinning, where we deposit layer by layer fibers into 3D structures. And third was the 3D printing, where we use digital light-based processing, where using the light, we cured a photosensitive polymer to make structures. So a little bit on that, as I mentioned with the laser graphene, that with the laser beam, you can write them. And as this is highly conductive, highly porous, using this kind of material, we explore different applications. We make biosensors like flexible biosensors, which can sense glucose and hydrogen peroxide, this kind of biomolecules. We also make skin-based electrode, for example, ECG or EEG. We always attach metal electrodes. But we wanted to replace those metal electrode with this laser induced based graphene. So we also stored that one. Also to energy devices, utilizing their high surface area and conductivity, you can also store a lot of energy and make flexible energy storage devices. In terms of electrospinning, as I mentioned, we deposit layer by layer fibers. The fibers range from micro to nano range, and you can make 2D, this kind of wall kind of patterns, and then we want to convert them to carbon to make this kind of 3D carbon shape. And lastly, the thing that I explored more in Karlsruhe was this 3D printing. You can see that as is 3D printing and light-based curing, you can make any shape you want. Here you can see some of the examples like different metamaterials or this kind of compliant joints, and where you can also move the carbon structures. And we utilize this 3D printed carbon materials for different applications. One of them was this tissue cell culture. So the carbon is, we showed that is very biocompatible, means our cells can attach to the carbon cells and they can grow on that, which later can be useful for different kind of injuries, either muscle injury, bone injury, this kind of injury repairing, you can use them. We also showed that this kind of carbon material you can also functionalize with other kind of nanomaterials. Here it is like zinc oxide nanowires. And the beauty of this one that we use the conductivity of carbon, the sturdiness of carbon and zinc oxide's photocatalytic activity to water filtration. Not filtration, but water remediation in a way. So we can put these materials in a contaminated water, and just putting in the sunlight, we can decontaminate the water. Also, we use them as energy storage devices by putting more electroactive material on top of the carbon. When I moved to IMDA materials with my Marie Curie in Madrid, uh, based on the previous research, we realized that carbon is a very good material for tissue engineering, for our health. Imagine you have a bone injury or something and you need a personalized scaffold to prepare that injury. So with the 3D printing, we can make any structures, and then when we paralyze them, you can see that they can shrink a lot with retaining the geometry of itself. So we can make the porous structures that mimic our bone at that geometry, and then we put our cells, and you can see how the cells can populate over the carbon. And we showed that how the cells can mature over it, how can cells grow over it. So that's the one I have been doing in the materials. And as I said, recently I moved to UPM and I'm continuing this work to study further, like the effect of cell, this kind of scaffold geometry, the effect of scaffold functional properties, uh, how this kind of properties can affect the cell growth, the injury requirement, and these kind of things. Also, moving from there, also we want to see if we can make synergies between this kind of carbon scaffold and other kind of cells to make biohybrid construct that can in future make more like intelligent system, thermoresponsive or light responsive system. So the future is quite bright, I believe, in this research. As I said, in UPM is basically at the center of Madrid. It's one of the oldest university in Spain. Um, it was not a university before. In 1971, it was just a school of how do you call it? This industrial engineering school. Later in 1970, they bring all the technical school in Madrid, put them together to make this technical University of Madrid. It has several campuses across Madrid. If you see the map of Madrid, they have in the west. This is far west outside Madrid. There is also one very south of Madrid, and Madrid is basically this region. This little elliptical region is Madrid. Our campus is right at the center of Madrid, so it's a very beautiful campus. It's a very beautiful location also. Nevertheless, this campus has total 8 departments, including mechanical engineering, materials engineering, chemical engineering, automation. And within this campus, almost 4,500 students registered there. There are total more than 300 professors are working in this campus, and over almost 800 researchers working in different research and R&D projects basically. So it's a beautiful place to be in. So if you are interested in visiting Madrid, visiting the university, you are always welcome. I'll be happy to host any of you from our university. So with that, I like to thank you all for listening to this brief presentation. And if you have any questions, I'll be happy to answer.
Thank you, Dada, for the wonderful introduction. And like a personal a question from my side is, you talked about like using of carbon in developing the thermocouple in like intelligent thermo intelligent some materials. So could you please brief on that, uh, on what exactly is the research aim in that region?
For example, recently we have been working on coupling thermoresponsive polymer. For example, there are certain kind of polymer like polyNIPAM or something. When you increase the temperature of the polymer, they basically squeezes up. So basically they dehydrate. That's why they kind of shrink a lot. And when you again hydrate them lower in a lower temperature, they again retain their original shape. So we want to combine the carbon and that material itself. So what will happen is that we, instead of putting them in a hot water or a cold water, we use the carbon as the conductive pathways with the Joule heating. Because if you know, like if you pass through a little bit of current there, because of Joule heating, the carbon structures heats up. So imagine you have a carbon layer and on top of that this polymer. So at a certain area, that carbon heats up the polymer itself. So in that way, you can have very differential like expansion or contraction, and with that you can have thermoresponsive intelligent material.
Okay, so thank you for the wonderful introduction into your research. And now, as I am already seeing that some questions are there regarding the interview only, like to make things easy for our audience, we have divided this conversation into three parts. First is your internships as an undergraduate in Shibpur, then your PhD journey across the USA and Mexico, and lastly, the postdoctoral research experiences in Germany and Spain. So let's start from the beginning. While at Shibpur, you did your internship at IIT Kharagpur and as well as IIT Kanpur. So could you please share how you prepared for these opportunities? Like what guidance will you give to me and my fellow students? And especially with the looming internship, we third years already have a compulsory subject for that.
So what happens is that we did the IIT Kharagpur internship in after the second years. And we remember that at that time, like in our batchmates, most of the students are not going for internship after the second years that much. So me and my friend, who is now a faculty in IIT Delhi, Ritik, we both went to Professor Amitabh Ghosh. I guess you all know Professor Amitabh Ghosh. So we asked him like, sir, we want to do something productive in particular in research projects or something. Could you please guide us there? And he then told us that why don't we apply for this Indian Academy of Science summer fellowship? If you have a good profile, maybe you can get it. I'm like, yeah, why not? We can apply for that. And we applied for that, and luckily we got it in IIT Kharagpur, Professor Suman Chakraborty. So that was in IIT Kharagpur. And actually, the next year, after third year, we build on that. We went to UC Irvine. IIT Kanpur one happened after I graduated um, from actually BESU. So the reason I went to IIT Kanpur is that I wanted to get more research experience so that I can pursue higher education abroad. So that's why again I contacted different professor, and luckily the work that I have done before with in IIT Kharagpur or UC Irvine, Professor Asutosh Sharma from IIT Kanpur, he liked it. So he gave me the opportunity to spend few months in IIT Kanpur. But it was always the drive of doing research, and I always wanted to stay in research. I didn't have any motivation or any intention to go to industry at all. I wanted to purely stay in academia, and that kind of derived me to to go to these academic internships.
Okay, thank you, Mansur, for that insight. Now, to the next part, could you briefly share your UC Irvine experience? Like what it was like, why working there, and what learnings you had from there?
Like again, like why working there? Like we wanted to do more. Like after we got the internship from IIT Kharagpur, we thought, okay, what if we take the chances of looking abroad? If we don't get the abroad, then we'll do some other internship in our country. So we are sending emails after emails to different professors and all. And as we did the internship in IIT Kharagpur, which was Swan Chakraborty, which is already a big name. So Professor Mark Meadow from UC Irvine, he said, "Oh yeah, I know Suman Chakraborty, so you can come and work here." So that worked out pretty nicely for us. Working there of course, there's a huge cultural shock for us in a good way, not in a bad way. It's a totally different, it was a whole different world for me at least. The work culture was very different. The thing that I liked the most, it's like when we see the Indian academic setup, there is still many research group has the little bit of barrier between the professor and the PhD students or the researchers because of this, the hierarchical things. But in Irvine, when I see it, it's like they treat the PhDs as equal to the professors in a way. So everyone has the, people don't feel any kind of hesitance to give their opinion even to the professors. If the professor is wrong, they can say, okay, you are wrong. This thing is like that. And that was kind of a very eye-opener to me. And I try to maintain the similar environment also in my research group now also. That was a huge learning experience for me.
Okay, so that was very insightful. Like the environment is much more calm and interactive. I get it.
Yes,
So
exactly.
since today's focus is in Europe, let's fast forward to a journey in Germany. So what motivated you to pursue opportunities there? And how did you prepare yourself for that? And from then, from the US to the Europe?
Um, so when I did my PhD in US, it was very like my professor was extremely nice. His name was Rodrigo Martinez-Duarte. Um, it was a very nice experience. But after 4.5 years, I stayed in US. Um, I wanted to personally experience a different culture. That was my main motivation because I knew that the research environment in US is also very good. The one in Europe would be also very good. So there was no doubt about um, research environment, research quality or anything. It was my personal choice or personal preference to experience other culture. So that was my motivation to looking for different positions in Europe. Luckily, in Karlsruhe Institute of Technology, the Professor Jan Corving, he liked my profile. Um, he was interested in my proposed research work, so that's why I went there. But yeah, Germany is also totally different environment. It's a very different kind of work settings. Um, so there was not much preparation, I would say, but you always kind of have to prepare yourself that it will be different than other countries. Every country has their own, um, let's say, work culture, cultural setup itself in the society. You need to be open to accept those challenges. You need to open to kind of like deal with those situations. When I went to first Germany, of course, the first barrier you will see is the language. Like they can speak English, but they don't speak English much either. Like in the not in the workplace, but in the local in the society. So to integrate in the society, you need to slowly adapt to it, and it takes time. But I think the effort is worth. It's really worth. Like um, I really enjoyed it. It took some time to be with the bureaucracy, the local, their administration and all those things. But it helps you to grow as a human, to be more open-minded, more acceptable. Um, so it's really worth it actually. I don't know if I could answer that question correctly, but yeah.
So yes, like I get it. Like multilingual approach is very important.
Mm-hmm.
And now, like, what was your experience in Spain?
So, it's similar thing. Germany, the society, the research culture is a different. Even in the academic setting, you kind of know how the academic work, the university system works is different. Same thing in Spain. They have their own like work environment, work setup, work administration, and all those things. So the similarity is the one that you need to learn the language. People are very nice in both places. They are very open-minded. They embrace you with their open arms. But for example, if you want to go to a market, the the guy or the girl at the store, they are not going to speak to you in English, right? So um, you need to little bit understand, and you need to start learning their languages. The more you learn the languages, the slowly you will understand that, okay, uh, you feel integrated in the society. Even like you don't have to go to a market or store. Each universities, most of the administration work happens in their own language. In Germany is German, in Spain is Spanish. So of course, nowadays we have ChatGPT, we have Google Translator. No matter how many times you use the Google Translator or ChatGPT, still it's hard to use this kind of app all the time. Unless you know the language, it's very difficult. I'll give you a small instance. Like sometimes what happens is that when I was a PI in Germany, they invited me to an um, accounting meetings as a PI for finances of my project, and the whole meeting was in German. I didn't understand I don't say that I don't understand a single word, but I didn't understand most of it. So I had to ask a fellow researcher, like, hey, can you please tell me at the end what are the key points I need to take from it? Like, yeah, don't worry, I can help you. But if you see yourself as a longer time in either Germany or Spain or any other countries where they don't speak English, it's much better to learn that language. I now speak a little bit Spanish. So here, like the situation is not that bad, but yeah, sometimes you can feel that okay, everyone is speaking Spanish and you are understanding, let's say 60-70%, but the rest you don't understand. And of course, you always have understanding is still okay. Speaking is the problem for most of us, that we hesitate to speak in other language. So, but as soon as you kind of overcome these kind of challenges, you then feel very integrated. And that's very important also for the jobs. If you want to find a job in Europe, where they don't speak English, they prefer you to speak the local languages, because you have to deal with the local authorities, the local people, the local amenities. And for that, learning the local language is very important. Yeah, there are other different multifunction, multilingual or multi national companies where they deal most of the things in English. Those things are fine. But in academia, yeah, they most you have to mostly deal with the local authorities. And for that, language is a big barrier for sure that you need to overcome.
Thank you, Mamsudar, for sharing your journey with such honesty and detail. Now, I already have some questions from the audience, so let's bring in the questions. The first question from Shayante asks, like, if Dr. Islam can discuss about some route to work permit in Europe.
Um, Generally, like in terms of work permit, I honestly know mostly about the academia. In academia, like um, you can. So, for example, many of the students or many of the people come to Europe to do a master's. Once you come to Europe as a master's, you already get a permit to stay, not to. And when you are doing your master's, after that they give you, I think, 1 or 1.5 years of uh, provision to find a job. Once you find a job, it's very easy to get the work permit. That's the most straightforward one. For me, it's the same. Like I always had an employment in either in Germany or Spain. So for me, work permit was never a problem. But only thing is like you have to kind of renew or extend your work permit time to time, depends on your contract, depends on your tenure there. For example, in Germany, my contract was kind of extended depending on the project. So every 1 year or 2 years, I had to renew my work permit. So yeah, like you if you have employment, it's very easy to get a work permit. There's no problem at all. That's the straightforward answer, basically.
Okay, so now the next question comes from Shailesh. Like, how to get an internship in the foreign university? He's a third year undergraduate student in mechanical engineering.
Um, it's it's challenging, but it depends on the funding actually. So many universities, they offer funding for bachelor's students for doing internship or spending the summer which is basically May till August, and that at that time. Um, or the professor whom you want to go has a funding and wanted to take students. Um, the best way is to approach the professor or the scientist you want to work with. You know, kind of the liking, like which area you want to work on. You want to work on manufacturing, you want to work on, I don't know, thermal or fluid mechanics or something. Then you choose the preferred, the universities that you want to kind of want to go. Search the professors there who are working on that topic or your preferred topic, and contact them directly. Like, contact as many people as you can, because remember that some most of the cases you might not get an answer from them, because many professors, they are very busy, or they are traveling or something. So they might not see your emails, because many times happens that they get, I don't know, hundreds of emails and your email is just lost there. So just keep contacting professors until you get an answer. Once you get an answer, and then see how things unfold. But many cases is the problem is the funding, because the students that come from abroad, generally they require some kind of stipend. When I actually first went to US, we didn't get any stipend. Fortunately, that time, the Indo-US Science and Technology Forum has a collaboration between US universities and Indian University. So Professor 𝗵-𝗶𝗶𝗵𝗵𝗲𝗿 and Meadow, they arranged us only the flight tickets to California. But thanks to our GAABESU community, they helped us a lot. They literally opened a fundraising for me and Ritik, and gathered a good amount of funds so that we can stay comfortably those 2 months in Irvine. So I don't think without that effort, like both me and Ritik's journey to California would have been possible. So we owe you a lot actually for that. And then yeah, like just contact professor. Like in Germany, I used to host a lot of undergrad students, both from India and in other universities outside India, for 2 3 months. And it was pretty, because I had the funding that time in Germany. Unfortunately, I don't have the funding right now in Spain, but there are different fellowship opportunities also from government of India or even other sectors. For example, in Germany, they have this DAD fellowship. So they also give opportunities for students to go there. Um, so yeah, you need to just keep contacting people, contacting the professors. Maybe you might get lucky and then um, get the opportunity to spend there.
Okay, Monsur, now, like you talked about the DAD fellowship, so I have
Mm-hmm.
another question for Manit. The DAD
Ah,
wise
okay.
fellowship has been discontinued as of now. So how does one get into Germany as a research intern, provided that funding is required and also the competition amongst programs have also risen for view of recent geopolitical conditions?
Like, it's a sad situation, but it is what it is. Like, what can you do? Like, but still, the other program means you have to just contact the professors or researchers there. They generally they have a lot of funding. Um, if they have funding, they can basically provide you with the stipend and you can stay there. Like I said, like in Germany, many students from I actually mentored at least 3 or 4 Indian students, they're like undergrad students, um, like third year students there for 4 5 months internship. So because I had the funding that time, so if you have the funding, it's possible. It's competitive, but yeah, it's not in our hand in a way.
Okay, the next question comes from Shonendu, that you have talked about some scholarships you got. So can you tell us more about that and how is the procedure to get that?
So again, like depending on which country you want to go, you have to look for the scholarships. I am not so sure about the undergrad scholarships at this moment, but I know for different master students or PhD students or postdocs, they have a lot of scholarship that you can apply for. In Spain, like they actually do a lot of things. Like for example, uh, if you are doing a postdoc, they have early career postdoc, little mid career postdoc fellowship, this kind of thing for PhDs also. If you if you have a host university, you can also apply for PhD program. You can apply for the scholarship. Once the scholarship is granted, you can do it. But you need to kind of contact with the host first, and with the host you have to write it. So again, the key point is making a contact with the professor and with the department. That's the key point here. And once you have that, you ask them like if there is an opportunity there to apply for this kind of fellowship. Sometimes also the universities itself offer them. um, in UPM, we offer like undergrad students also to spend few months in US or other European countries uh, through fellowships. But these fellowships are also very competitive. You need to have a very good CV for that one. So yeah, again, the key point is to contact with the professors basically to make the contact. And once they like you, like your profile, try to find the way. Every country has their own set of fellowship schemes, scholarships, and funding opportunities.
Okay. So it's competitive and like
Yeah,
the contact with professors are a key point.
yeah, exactly. That's the only thing. Even if you are a undergrad students, and like in US, you can do direct PhDs without doing a master's basically. So, but you need to have a very good profile and all. Um, so contact the professors in US, the one you want to go. Right now, the situation is in little bit difficult, challenging in US, but still, if they have funding, they can host you, give the fellowship, give the assistantship to you. But same in Europe, you need to have a master's degree, so you can come in Europe. Actually, many countries, the masters are kind of like free. Like you don't, even though the fees are very minimum, but it's not much. I know that in Germany, so my wife did a master's in Germany, and for her the semester fee was around like 300 euros, which is equivalent to I think 30,000. I think not not that much. So if you can do masters, and in Germany now they are promoting more and more masters program in English. Um, so is there are more opportunities now than before. So if you do a masters in these countries, and then during this masters you kind of do other internship during your masters, do a research stay outside in other country, and through that you make contacts, and then you can either go for job or uh, higher studies depending on what you want. But this 1 year or stay in another country helps you a lot. And also the question about this work permit, what I noticed that also that if you have a degree from this country, either Spain or Germany or Netherlands, whatever, um, if you have a degree from that country, it's easier to find an employment there. So yeah, these things you need to kind of like look forward to.
One more question we have. What key skills or experiences from your time at Shibpur proved to be the most valuable in building your international research career?
Okay. One thing that I must say, at least that what I felt, is that our education system is very strong theoretically, and that's a very key point, because what I see or what I noticed in US or in Germany, at Germany is still okay. uh, they don't uh, they don't rely too much on the theoretical background of things. So as in Indian system, we kind of learn the fundamentals of different phenomena, mechanism, different scientific topics. In other countries, at least in engineering degree, they are more hands-on than learning the fundamentals. And that might be helpful for different those like hands-on experience for industrial approaches, but for academia, or at least in research and development, understanding, learning, and knowing the fundamentals the key point. And that is the like that helped me, the study that I did in IST in Shibpur, that helped me a lot. to kind of have a interest for learning the fundamentals. The way we are taught applied mechanics or fluid dynamics or manufacturing, these things are very different in other countries. I'll just give you a brief example. Like, so how we are taught applied mechanics in BESU, right? In Shibpur. I took a similar course or the same course in Clemson. In Clemson, it was kind of like 30% of what I learned in Shibpur. There, they will give you a practical situation of like, okay, this is a practical situation, you do it or you learn it. But without knowing too much details of the fundamentals. But in Shibpur, we had to know everything about applied mechanics. Even our textbooks are like that. So that's amazing, and that's why I think um most of the, like, if you see the Indian professors, like professors from Indian origin, they are more heavy on fundamental research, or they know more of the fundamentals of things than I would say other professors from other nationalities. That's one very valuable things that actually helped me to explore different things to their core. And once you know this, the fundamental basis, you can build on that thing for different other things, basically. And I believe that helped me a lot in building um, research careers, while writing grants, while writing fellowships, proposals. These things help a lot, I believe.
Okay, Monsur. So any more questions there? Like, I don't see any more questions now. Yes, we have one more question. And Nishant asks, like, what is the opportunity for MS in Spain or other European countries compared to IIT in civil engineering structural? He wants to work in an industry after it, so suggestions are welcome.
Um, I would say that this not I don't see the comparison is too much valid, whether it's IITs or in other countries in Europe. Um, it's like where you want to stay. Like as I mentioned before, if you want to have a career out, like in abroad, either in Europe or in US, it's better to have a degree, university degree from that country. Once you have that one, that's give you a time and opportunity also to learn the language, learn the culture there, and when you go to an interview, those things reflect in your interview, and for that the companies or the industries, uh, they might have more chances of hiring you than you are applying from India to other countries. um, but other than that, there is not much of a difference. If you want to do an MS in Spain or in European countries, there is always opportunities. You can always apply for MS in different program. As I mentioned, now in Europe, more and more MS programs are opening in English. Even in our university in UPM, even I don't know, like 6 7 years before, also there was not, I guess, one or two MS programs. Now we have quite a bit. At least in our department, there are like five programs that's converted, that taught in totally English in for MS. So and these things are increasing more and more. So you can always apply. In like depends of which country you are going. The MS program might be different. For example, in US, in Germany it's 1 year. In Germany it's 2 years. In Spain, it's either 1 year or 1.5 year of MS program. In between, also you can take a gap, do an internship, do an either academic internship or industrial internship. You can also do all those things, but there is a lot of opportunity for MS here also right now.
That was insightful. Now we have another question from Shivam. You talked about making a good profile. So can you elaborate on it, like how we can make a good profile for research in foreign countries?
Um, like research in foreign countries or in India, they are same. You have to be persistent. You need to do good research. You need to do high quality research. Uh, there are in academia, if you there is a whole lot of race now, having, I don't know, publishing 20 papers a year or publishing 2 papers a year. But honestly, I believe publishing or publication has importance, but having a good research is more important. If you have a good research, and good research is very subjective, of course, but you need to know like what is good research in your area. That you need to have a knowledge for that. Once you make good research, automatically things will unfold. Automatically, you will publishing good in good journals, and that good journals uh, like adds points to your resume. Of course, as a researcher, you will do good research, having publications and all, but other than research, you need to also think of other thing, which is like leadership skill, and that also adds to this good profile also. For example, whenever you apply for a, I don't know, assistant professorship or senior researchers, they want to see how good of a research contribution you have. Do you have a leadership skill? And do you have international commitments basically? And international commitment doesn't mean that you have international experience, research experience, or international stay in other countries. They want to see how many international collaborations you have. So they want to see these kind of things. And in terms of leadership skill, you should have mentorship. Like you should have skill for mentoring undergrads or grad students or PhDs, or you be the part of an organizing committee for a workshop or for a conference for summer school. So these all those things adds up, and that's how you build a good research profile. Um, it's same in US or India, wherever you go or anywhere you go, it's the same. So you need to think of these three things like research, contribution, leadership, and international cooperation.
Some more questions. You have worked on the semiconductor research, so can you please highlight some career opportunities in semiconductor VLSI, like universities to try for masters?
Um, like I haven't done much of a semiconductor research at all, actually. Like the work that I have done is mostly material science, and mostly carbon materials, development of carbon materials and their applications, mostly in biomedical applications. So, uh, yeah, I'm sorry, I am not so aware of the universities good for VLSI like things. But you can always, if you believe in this QS ranking or US news ranking, you can just search in Google like which universities are good in semiconductor research. Um, yeah, sorry, I really don't know much about the universities
Yes.
on that thing.
Yeah, not a problem. Uh, Now we have two questions. I will go one by one. In research, can carbon polymers, example graphene, CNT, or composites be used for robots? Specifically, is focusing on carbon fiber bodies.
Yes, depends. Like what you want to do actually. Like depends on your project, depends on your research. For example, in my research, we want to make these carbon-based robots or carbon-based biobots in a way where we can have the carbon as the chassis or the framework for the robot, and we can apply other cells which are more, um, for example, muscle cells which can contract and expand and have this kind of movement. So if you can combine them, synergize them intelligent way, you can have a biobot. And this carbon chassis, either you can make it with the 3D printing or carbon fiber or anything. So um, yeah, there's a huge opportunity for these carbon-based materials. Carbon fibers are actually nowadays using in different lightweight materials for our shoes or different kinds of leathers or even different textiles, different structural materials are making up carbon fibers. So yes, there is a lot of opportunities on that carbon-based field actually in robots.
Another very technical question. What trade-offs exist when choosing carbon fiber versus titanium for a robotic exoskeleton, provided that the durability and strength is paramount?
Uh, Again, robot can be different. It can be like humanoids. It can be also a micro robot that can go inside your body and do some surgery. So depends on which one you want to use. For example, if you want to do this microsurgery, titanium might be good, but making that tiny robot with titanium will be very expensive. And even the titanium is biocompatible, is very stiff and strong, it might damage the inner tissue while operating on them. Whereas carbon fiber, as you say, there's a trade-off, like it can be softer, on the same time durable within a biochemical environment, and do the same task with a lower cost effective way. Um, so and with the similar properties. So depends where we want to use the materials. But maybe in future, like if you think about a humanoid robot, titanium might be very durable, very strong and everything, but maybe you can think of a different chassis for the inner core and just the skin, uh, with the carbon fibers. Perhaps that can be a way to go also. But of course, the working environment might be different than titanium than carbon fiber. It really depends on your application field.
Okay, so here are some more questions. What challenges did you face while transitioning to research environments across the globe, and how did you adapt to it?
Um, yeah, the main challenge is always the language, I believe, like because I travel from US, from Mexico to Spain to Germany, always the language is a big barrier. Once you even first you land in a country, you will see like people are speaking a different language, and it takes time to really understand like what they're saying and all those things. And then slowly, when you want to integrate yourself in the society, because you need to apply for your work permit, you need to apply for your license, you need to apply for your health insurance. All those things also require, there are different bureaucracy, there are different official permissions and language, of course, there. Uh, at times, it might be frustrating, but you need to be patient. You need to think also that what I think that these things, this paperwork or these things are temporary. Learning a new language, integrating has a bigger purpose in your life. Those kind of things helps a lot, and I am always driven by my scientific research. So as long as I have a good research environment where I can thrive, the rest of the things becomes secondary to me. So I think that's kind of helped me to adapt quickly. And also, once you start talking to people, make friends, things have become easier. Like when you go out with your friends, with the friends from that country, they help you to kind of be more integrated within the society. And fortunately, I made good friends both in Germany and Spain, and they have been like strong pillars in both countries for me, and I have good relation with all of them in both countries.
So being multilingual is coming up again and again. Like it is a
Yeah,
very
yeah.
key point. I
Yeah, if you want to stay in Europe, yeah, you need to learn other languages. Otherwise it's very difficult. As I said, like now, even I know little Spanish now, and I am now enrolled also for serious Spanish lessons in UPM. So I will take courses for that one so that I can learn Spanish properly. Because even though I need to take classes now, mostly in the master's courses, so that they are taught in English, but in future I also want to take courses in Spanish, mostly for the bachelor level courses. So learning language is very important.
okay. So the next question comes from a MSc Math student, and he now wants to go to data science and artificial intelligence or in quantum technology. So is there any opportunities for him there? Like how can he get there?
Oh yeah, like data science, artificial intelligence, or quantum, they are like the hot topics actually. So, in Europe, one of the main funding source is European Commission or European Union, and they fund different research programs through different funding programs basically. Uh, and when I look for the funding opportunities, like either artificial intelligence or quantum technology pops up like several times. And these are the hot topics. So I believe there's a lot of research going on, and there's a lot of startups, new companies are also emerging on those fields. So there is a huge amount of opportunity there. You just need to, as I said before, you just need to contact the company, contact the people. Now we have LinkedIn, so you can also contact different companies through LinkedIn. Contact directly. You can find their emails. The professors also contact them. If you have an opportunity to go to international conferences, talk to different professors, different researchers. Uh, Again, the key point here is contact. Once you make a good contact, other opportunities unfold. So that's one thing I actually did. Like during my, like believe me, during my PhDs, I probably sent emails to more than 200 professors, more than 200 professors. And probably I got replies from 60, 70. Same during my postdoc. I don't know how many places I actually send emails. It's also probably more than 100, 150, something like that. Like you should not be tired or shy of sending your CV, your emails. If you believe in yourself, that if you believe that you have good work, things will fall through. Definitely.
Now, a last question for MS with orientation to industry job. Is it good to gain some work experience in India and then apply for it, or should we go directly? Which has a higher chance of acceptance?
It depends. It doesn't. If you want to do a master's abroad, um, that thing doesn't really matter much. Like if you have a job experience or not, I believe they don't add up that much on that. So you can directly apply. If you want to, I know that many cases to go abroad, you like many of my friends actually did that. Like if you want to go to US to do masters, you need to have they have a very high semester fee. So many of my friends worked for like several years to kind of save some money for applications for at least first semester or something for the fees, and then they go there for masters. Same like many, even my wife, she did like 2 years of job and then she came to masters in Germany. So, but that doesn't like has much effect on that. Of course, once you want to go to industry, any kind of job experience helps. Any kind of job experience, whether it's in India or an outside India, that always helps.
So before we wrap up today's session, a question from my side. If you were to give just one line as a piece of advice to the upcoming engineers and researchers, what would it be?
I just want to like one line will just be fearless. Like don't be shy of uh, contacting people. Don't be shy of questioning things. That's all. Like just be fearless. Like there is once you um like never stop asking questions. That's the thing. The rest will just come along. So just be fearless, true to your work, and do your bachelor's very well.
Thank you, Monsur. That was absolutely point on. The whole session was very interactive and energizing. As we come to the close of this wonderful session, I want to express my heartfelt thanks to our speaker, Dr. Monsur Islam. And thank you for taking us in this inspiring journey from Shibpur to US, Mexico, Germany, and now Spain. Your insights and advice have given us a clear vision as to what is possible with persistence, preparation, and determination. I also want to thank our very wonderful audience, students, faculty, alumni who joined us live today, as well as those who will catch the recording later. Your questions and energy kept the session truly engaging. Before we sign off, a gentle reminder, stay connected to the GAABESU and IIT Shibpur Alumni Network. This webinar is just one of the many ongoing in the series designed to empower a student community and celebrate alumni achievements. The recording will soon be available on GAABESU YouTube channel, and we will also share the link via email and social media. Please feel free to revisit it and share it with your friends. Until next time, take care, stay
Uh,
curious, and
Dr.
keep the
Islam,
Shibpur spirit.
Dr. Islam, before you leave, I'm sorry to keep you at bay. Sorry, Mr. Carr, to cut you off right there. Wanted to ask you a technical question. Uh, you mentioned that you were working on some carbon-based scaffoldings, right, for your tissue engineering.
Yes.
Uh, I, sorry again. I'm so sorry to cut at the last moment. I just wanted to ask, how were you testing the toxicity and the bioactivity of your materials, like in vitro? I know you can do tests within the body itself, but what were the methods of testing them outside the body? Ne?
No, so far we have done only the in vitro one. We didn't do in vivo, and that's one of the things that we are doing now. The thing is that the 3D printed carbon, we are the first one to try these things for this in vitro test, but we are mainly doing by culturing cells over it and then checking their cross proliferation, differentiation, this kind of things so far. But soon we will start the in vivo experiments within mice and then see how it goes. But in terms of bioactivity, the carbon scaffold we are making right now, they are still not bioactive. We are investigating different other ways how to make those carbon scaffold more bioactive. So that's a also deep research line that we are working on now.
Lovely. And can I ask you once again, what kind of tissues are you targeting on? Like, if you plan to do it in vivo and probably in a mice, what kind of tissues are you targeting for?
So right now, depending on the carbon is very stiff and strong, so that's why we are targeting bone right now. Like we have tried in vitro, like this cytocompatibility test for neurons, for muscle cells, but for those carbon is too stiff. Even though they show good biocompatibility, I don't think the practical use will be that much for those other tissues. It's mostly currently we are just doing bone.
So I did a couple of projects during my undergraduate, and we were working on bioactivated bioglass 4,5-SY, well, back in Florida. Well, we were working on the third generation of that, and we did experimented with some graphene oxide to develop those scaffolds. Well, it didn't went much ahead because I left the project and got projected. But would you mind if I contacted you over email to discuss more about it?
Yeah, sure, definitely. I will love to talk to you about that for sure. I'll
Yeah.
be happy.
Oh, thank you so much. I'll send you an email and we can decide on time then.
Yeah, sure, definitely.
Okay, thank you
So,
once again.
yeah.
Lovely talk.
Thank you.
Yeah.
So that's again like connecting alumni with like other people of the same research background. So finally, we wrap up this session. And until next time, take care, stay curious, and keep the Shibpur spirit alive. Wishing you all a wonderful day or evening wherever you are. Thank you.